Okay, here's a thought to start us off. What if artificial intelligence could actually genuinely imagine or be creative, maybe even have intuition?
Mm-hmm.
Not just remixing stuff it's already seen, but something more.
Yeah, that definitely challenges how we usually think about AI, doesn't it? Its core
It
capabilities.
really does. Welcome to the deep dive. Today we're getting into something, well, I think it's truly compelling. The super time complex neural network, STCNN for short.
Right.
It's this pioneering hybrid network from Sophimatics, developed by Gerardo and Giovanni Iòvane. And it seems like it's aiming to pretty fundamentally redefine AI's potential.
That's a good way to put it, redefine.
So our mission today for this deep dive is really to unpack how this new architecture, this STCNN, is designed to tackle some really fundamental limitations in current AI.
Uh-huh, the big ones.
Exactly, especially how AI struggles with, understanding time, context, all those complex things that feel very human.
Human-like cognition, yeah.
We're going to explore how it's hoping to bring AI much closer to emulating parts of our minds, moving beyond just like finding statistical patterns.
Right, beyond correlations to something more like understanding.
And the sources we're drawing on today, they come from some pretty cutting-edge research. They really highlight the gaps in traditional deep learning and, crucially, how the STCNN is trying to fill them.
That's exactly it. I mean, what we seem to be looking at is a potential shift, moving from AI systems that are fantastic pattern recognizers.
Yeah, they're amazing at that.
Amazing at statistical inference, definitely. But shifting towards something that, well, truly interprets, something that might grasp intent, meaning
Okay.
it's really about tackling those inherent problems that, standard deep learning models face when they hit the real world, which is messy, dynamic, contextual.
Always changing, yeah.
Yeah.
So given those limitations, especially how current AI handles time, which often feels very linear, very basic,
Mm-hmm.
what's the groundbreaking approach here? I mean, what core problem is STCNN really trying to solve?
Well, it boils down to a pretty significant hurdle for the traditional ways of doing things, the connectionist networks, deep learning.
Right.
Their representations are often static, and their processing of time is, like you said, very linear, often quite simplistic. They just struggle with things that unfold over time, the when and the why behind events.
They don't get the nuance.
Precisely.
Hmm.
Current state-of-the-art AI, and this isn't just a new observation, researchers like Pang and others recently, but even folks like Vermeter and Leonard, way back in '89, saw this coming.
Really? Back then?
Yeah, they flagged that these systems are fundamentally limited in how they represent and process time, intention, context, all that rich stuff. They're just missing that deeper connection, how events link through time and meaning.
Okay, so that sets the stage perfectly for the big promise of STCNN then.
Exactly.
It's not just about shuffling or mixing data, it already has.
No, it's aiming higher.
The goal seems to be equipping AI with abilities we normally just think of as human, right? Real imagination, actual creativity, even intuition.
Yeah.
Can you imagine an AI that doesn't just predict the next word, but actually conceives something new or figures out meaning from incomplete clues?
That's the ambition. It's incredibly ambitious, you're right.
So how does STCNN actually try to do this? You mentioned it's a hybrid network.
Yes, exactly. It integrates connectionist learning. That's the pattern spotting strength of neural nets we know.
Right.
But it combines it with symbolic abstraction, which is more about concepts and rules, and this really fascinating idea of multidimensional temporality.
Multidimensional time.
Okay. Its design is definitely ambitious. It's trying to emulate, or at least get closer to, the complex structure of human thinking by linking up sensory input, context, and this more complex time model.
And that hybrid structure is key.
It's absolutely key. It's what lets it adapt its understanding based on the context, based on the meaning, not just the raw data points. So it moves beyond just seeing patterns to maybe understanding what they mean and when they matter.
This complex time model, that sounds like the really novel part. It breaks AI free from just thinking step by step linearly.
That's the idea, yeah.
Can you help us visualize that?
Sure. Think of a standard graph, a Cartesian plane. You've got the x-axis, left to right, representing time, past, present, future. Pretty standard.
Okay.
Now, add the a-axis, bottom to top. This represents cognitive dimensions, things like memory down low, moving up through, say, creativity, maybe imagination at the top.
Right, like a map of mental states over time.
Sort of, yeah. Now think about current generative AI, the large language models everyone's talking about. Where do they sit on this map?
Based on what you said, present moment creating stuff. So intersection of present, and creativity.
Exactly, you nailed it. They operate largely right there. Present, creativity. They're brilliant at generating novel stuff now, based on patterns learned from huge data sets.
But limited to that point, more or less.
Largely, yes. So what about STCNN? How does it break out?
That's the million-dollar question.
Well, the claim is that STCNN is designed to span the entire plane, not just that one intersection.
The whole thing. Past, future, memory, imagination.
That's the goal. It aims to do this using what's called a complex time model. Mathematically, you might see it written as T equals A plus IB, or just as coordinates, AB.
Okay, complex numbers. I remember those vaguely.
Yeah. So the A part, that's your familiar linear time, past, present, future, the straightforward arrow.
Right.
But the A part, that's the kicker. The A signifies that imaginary dimension from complex numbers. It lets the network process time not just as a line, but with other interwoven aspects, things like causality, intention, maybe potential futures.
So it's not just what happened, but how it relates, potentially.
Exactly. Think about how we experience time. We can mentally live a memory, right? Or pre-play a future scenario in our heads. It's not just recalling a fact or predicting the next data point.
Yeah, it's much richer.
That's what this complex time model enables, or hopes to enable. A much, much richer, deeper, more nuanced understanding of time.
That ability to span the whole plane using complex time, that sounds like a really profound shift. But, the proof is in the pudding. How does this actually translate into results? Is there real-world evidence?
Does it make a difference? Yeah, that's the critical question. And studies do show that embedding time in contexts like this really does support more complex cognition.
Okay.
There's a concrete example from Peng and colleagues in 2023. They used a deep neural network analyzing EEG brainwaves.
Brainwaves?
Yeah, to detect driver fatigue. Now, the key was exploiting spatiotemporal patterns, subtle changes in brainwave frequencies over time.
Not just a snapshot.
Exactly. And by doing that, they hit 87.55% accuracy, which is pretty impressive.
Wow. Yeah.
And the point is, traditional sequential models, the ones that just process data linearly, step by step, they often miss these crucial, subtle, time-based patterns.
Which means the benefits could be huge for anything needing real-time awareness, right?
Right.
Or adaptive control systems, where you need to know how things are changing second by second.
Absolutely critical. It's not just what's happening, but how it's unfolding, like you said.
Yeah.
And this idea of hybrid architectures, combining symbolic stuff with connectionist networks like STCNN does, it isn't totally out of the blue.
Okay.
Wernter and Leonard, back in '89 again, they actually proposed a 3-level network. It was designed to figure out conceptual links between words.
How did it work?
It had a neural layer for pattern matching, kind of like today's networks, then a layer for specific concepts, and crucially, a logical rule layer for symbolic reasoning.
So mixing different approaches even then.
Exactly.
Yeah.
And they had decent success, even on that simpler task. I think it was 88% correct on relationships it was trained on, and impressively, like 77% on relationships it hadn't seen before.
That's pretty good for unseen data.
It really highlighted even then how important having interpretable rules and combining approaches could be. STCNN is basically taking that concept and scaling it up massively for much more complex, high-dimensional tasks, aiming for better generalization, better adaptation.
It's also interesting you mentioned STCNN uses symbolic reasoning during both training and when it's actually running during inference. And it combines that with the neural computation side to decide how to act. Can you give an example of that hybrid approach in action?
Sure. This kind of mix is already used in some areas, like image analysis. Think about recognizing a picture.
Okay.
Symbolic reasoning can provide the high-level understanding, like abstractly knowing the features that make something a house.
Like walls, roof, door.
Right, the conceptual parts. Meanwhile, parallel neural networks are really good at the low-level pattern matching, identifying the specific pixels that form a window or a door within that image.
So, best of both worlds.
Kind of.
Yeah.
Research by Rowley and others back in '95 actually found that for certain complex jobs, these hybrid systems often outperform systems that use only one method.
That really leads to a bigger question, doesn't it? What does this push toward integrating symbolic reasoning and neural nets tell us about where AI might be heading?
Yeah, I think it points to something pretty fundamental. If we want AI systems that are truly adaptive, systems that can interpret things in complex situations, we probably need to move beyond just relying on one single approach. Symbolic reasoning gives you that abstract understanding, rule-based thinking. Neural nets are amazing learners from raw data.
You need both.
Arguably, yes. Combining them lets AI potentially not just spot patterns, but understand why they're significant. And this becomes absolutely critical in high-stakes areas.
Like medicine.
Exactly, like medical diagnosis or treatment recommendations. You need that symbolic abstraction layer for interpretability. You need to know why the AI is suggesting something, not just what it's suggesting. That's how you build trust.
Trust is huge, yeah. Okay, so moving even deeper,
Yeah.
you mentioned STCNN embeds ontologies, both semantic and spatiotemporal ones. Can you unpack ontologies for us? What does embedding them mean?
Right. So ontologies are basically structured knowledge frameworks. Think of them like detailed maps of concepts and how they relate to each other.
Okay, like a knowledge graph.
Similar idea, yeah. STCNN uses these maps for meaning, that's the semantic ontology, and for how things relate in time and space, the spatiotemporal one.
And why is that important?
Well, it directly tackles a criticism raised by Kuhn and others around 2006. They basically said a lot of AI lacks semantic commitment.
Semantic commit.
Yeah, like a deep grasp of meaning and context. They argued AI needed much better ways to represent context. Ontologies are a powerful tool for providing that structured understanding.
And it connects to ideas from cognitive semantic. You mentioned image schemas, prototypes,
Yeah.
things that are apparently quite central to how we think.
Exactly. These are concepts from studying human cognition. Image schemas are like basic mental blueprints for understanding experiences like containment, being inside something, or path, moving along something.
Huh?
Prototypes are the typical examples we use to define categories, like a robin might be a prototype for bird. And radial categories let us understand how concepts relate flexibly to a central prototype, but can stretch out in different ways.
So STCNN tries to build these human-like knowledge structures in.
That's the aim. By embedding concepts within these rich, high-dimensional semantic and spatiotemporal ontologies, it's trying to better mirror how human knowledge seems to be structured, and especially how our understanding of meaning interacts with our sense of time and space. It's about building an AI that organizes meaning in a way that's closer to ours.
Okay, so let's try and recap this. It's a really compelling vision. The Super Time Complex Neural Network, STCNN, it sounds like a truly foundational piece for Sophimatics,
It seems to be, yeah.
designed to actually operationalize cognition using this potent mix of symbolic abstraction, context, and this layered complex time.
That's the package. And the grand goal here, the big ambition, is to create systems that aren't just processing data, but are capable of genuine interpretation, maybe even ethical reflection down the line.
Right.
It's about moving way beyond just finding statistical links, beyond those low-level learning mechanisms that drive so much of AI today. The aim is for a system that can really understand, not just process.
Understand? Okay, so for you, our listener, maybe here's a final thought to chew on. If AI can truly grasp context in this deeper way, if it can span memory and imagination across this complex time plane, maybe even engage in ethical reflection, what new possibilities does that open up? And what are the challenges for how we might collaborate with AI, how we understand intelligence itself?
Yeah.
What does it actually mean for AI, not just to process information, but to genuinely interpret and understand, maybe in a way that starts to resemble our own complex cognition? Lots to think about there.